Hi, in this last session of trigonometry chapter, we will derive sine rule and cosine rule for a typical triangle. Now let us look at this triangle ABC, whose vertices are given by capital A, capital B and capital C, and the sides are given by small letters A, B and C. And let us now choose any two vertices and drop perpendiculars from them onto the opposite sides. So let us say that we drop a perpendicular from vertex B onto the opposite side AC, and similarly we draw a perpendicular from the vertex A onto the opposite side BC. And let us label these points where these perpendiculars meet the opposite sides as capital D and capital E. Now in the right triangle ADB, we can write the sine of angle A as the ratio of side BD divided by the side AB, which is the length C. And in the right triangle CDB, we can express sine of angle C as the ratio of BD to BC, which is length A. Now we equate BD for these two expressions and get C sine A equals A sine C, which implies sine A by A equals sine C by C. Let us label this as equation 1. Now we look at the right triangles AEB and AEC and write the expressions for sine B and sine C. In triangle AEB, we can see that sine B equals AE, side AE, divided by side AB, which is length C. And in the right triangle AEC, sine of angle C equals side AE divided by side AC, which is length small b. And by equating the expressions for AE, we get C sine B equals B sine C, or sine B divided by B equals sine C divided by C. And that's the other set of equation which we will label 2. Therefore, from the two equations 1 and 2, we obtain our sine rule, which says sine A divided by A equals sine B divided by B equals sine C divided by C. We must keep in mind that A, small a, is the length of side that is opposite to angle A. Small b is the length of side opposite to angle B, and small c is the length of side opposite to angle C in a triangle. And this is our sine rule. Together with the cosine rule, which we will derive shortly, the sine rule is useful to solve various real-world problems that involve distances and angles and heights, where we can represent them in terms of various triangles. Now, in order to derive the cosine rule, let us once again look at the right triangle BDC. We can write A squared, which is the square root of the side BC, which is the hypotenuse, as the sum of BD squared and DC squared. and we know that DC is AC minus AD, which is small b minus AD. So let us replace that, and we get BD squared plus small b minus AD whole squared. And if we open it up, we get BD squared plus AD squared plus B squared minus 2B times AD. And we can see that in right triangle ADB, BD squared plus AD squared equals AB squared, which is small c squared. So let us write that BD squared plus AD squared becomes small c squared, plus we have B squared minus 2B times AD. And in the right triangle ADB, AD is hypotenuse times cos of angle A, that is small c times cos of angle A. So we get here 2 times small b times small c times cos of angle A. Therefore, we get the first equation of our cosine rule, which says small a squared equals small b squared plus small c squared minus 2bc cos A. And in a similar way, we can get the other two equations, which are b squared, small b squared equals small c squared plus small a squared minus 2 times small c into small a times cos of angle B. And the final equation, which says that small c squared equals small a squared plus small b squared minus 2 times small a into small b into cos of angle C. And these three equations set comprises our cosine rule. So now we have covered all the theory of trigonometry chapter of standard 11th of CBSE, and we will now move to solving some example problems. So see you in the next session.